me all right?
Can you hear me?
All right, cool. So, as Federico said, but I don't know Spanish, so I don't know what he said. Could have said anything. But I'll assume that he introduced our talk. It's a lightning talk. We committed to doing this like 3 weeks ago, so we put this together fairly quickly. So it's only 20 minutes. We might run a little bit over. But basically, this talk is about IDA Pro. How many people here use IDA? All right, awesome. Good number.
How many people write IDA Python? How many people IDC, anything? IDA panel? Anybody?
Okay.
Nice, 5.
So, a quick intro. We'll go into what we do. So we work for the Zero Day Initiative, part of Tipping Point, part of HP. Basically, we are the team that gets all those ZDI vulnerability submissions that come in. We verify the vulns, we report it to the vendor, we reverse engineer what the bug is, we find other bugs, and we do some exploitation stuff. We basically use IDA every single day of the work week. So, in doing so, we run into a lot of problems. So as you can imagine, some of the stuff that we get to the ZDI, sometimes it's really well documented and makes our jobs really easy. And sometimes it's a chunk of hexadecimal that if you send it 100 times in a row, it'll crash the service. We get a report like that. No documentation at all. So sometimes we can verify the vulnerability in a day or 2 days, and sometimes it might take a couple weeks because we have to reverse engineer an entire protocol and figure out what's going on, and it's quite a hassle. So we primarily use IDA, like I said, and we run into a lot of problems doing so. So you can imagine, let me give you a little example. So say somebody submits a vulnerability in Flash. Comes in today, and I'm assigned to verify that vulnerability. So I do all this work in IDA, I reverse out the vuln, I figure out where the parsing is, I find a bug, maybe I find another bug, and I store all that information in IDA. I write all the comments, and I name things appropriately, do it all via my style, which may not be your style or your style. It's how I do it. And the biggest problem we encounter with that is that there's no way to retain that information. So say 2 months down the line, another Flash vulnerability comes in and it's assigned to him. Now, I've done all this work, and I've spent all this time by myself reverse engineering the binary. How do I transfer that knowledge to him? How do I retain all the information of all the stuff that I've reversed out and be able to transport that to him in a way that won't take him a long time to actually understand what's going on?
Yeah, or it costs me to listen to him for like 2 hours.
Yes, because currently what we do is I'll be like, here's my IDB, and let me look over your shoulder and tell you, oh, that's right. No, I was wrong there because I was drunk. I don't know what this is. It's a long process. So this whole talk is about how we can kind of solve that. You have other problems. You have different versions. So say I did all that work on one version of Flash, they patch it, and then there's a new version of the IDB. So how many of you guys have tried to port information from one version of an IDB to a new one? Okay, you binned it for it? Yeah. Okay, so
try it against MSO.
MSO.dll for Microsoft Office is gigantic. I mean, trying to do that, trying to port all your information from one IDB to another one is a huge pain. And the only big tools that are out there that do that are bindiff. And it does it by diffing the two databases and trying to figure out what changed and try to port all your comments and naming information, type information from one IDB to the other. And the biggest problem is over time as well. So say I do all this work on one product and I reverse a bunch about it. 6 months down the line, I may reverse a little bit differently, and I go dig up my old IDB and I load it up, and I look at it and I'm like, what was I thinking? I'm like, that is obviously wrong. That's wrong. I don't even know why I named it that. I mean, everything is based on text. All the naming, all the comments, it's all text. So you have to be consistent with your naming, or else you can really lose yourself. And the reason that happens is because you're limited by the tool you're using. You're limited by IDA. We'll get into why in a second here. So for example, information that I like to retain from one IDB to another. Naming information, symbols. I want to know if I name a function for what it does, I want to be able to have that in my new IDB. I want to persist that. Things like the organization of the binary, or the developer, how he designed his code. Maybe 5 developers worked on the same binary. They all code differently. Maybe one of them made the value 0 a good return. Maybe another one made the value 1. Maybe one guy decided, maybe one module is this call and something else. Like everyone, the developer designed the code in all these different ways, and you have to reverse engineer that, get inside their head, and then figure out how to save that information. So if I look at that IDB in a year, I remember what I figured out. So you also want to keep things like type information or object scope. So if you ever exploited, say, a use after free vulnerability, any of the browsers, Firefox, IE, Chrome, all that kind of stuff, you need to know exactly where a variable is in scope, when it gets created, when it gets destroyed, why, all the different paths. Essentially, that's a use after free, right? A use after free is used after it was already freed. And you should be able to find that in a disassembly. So you have to reverse all the different types of object scope, all the different constructors and destructors, and all the methods that all those use. I'd like to keep all that information. I'd like to be able to keep things like execution and data flow. So if I'm looking at a vulnerability in IDA, and I look at it in the debugger, and I figure out, oh, it goes over here to over here, this dynamic call jumps over here, I'd like to be able to take all that execution flow, get in my IDB, and store it in a way that I can actually, look at it in a new IDB. I can transfer that knowledge. And of course, you've got things like type information, but that's similar to object scope, where you actually figured out, say they're using C++. I want to know, how does this object inherit from this object? What does the hierarchy look like? When we parse the RCTI data out, how do I store it all? And again, IDA only provides you text-based representations of how to store that kind of information. And as you can probably guess, text is really not the way to describe that. So how many people, show of hands, reverse like this? This is from my IDB. All right, at least you do. So for an example, this is straight from a T2 embed DLL that I reversed a bug out of Internet Explorer's TTF, like font parsing. And as you can see, I do a bunch of really bad things here. Way up on the top, the function I'm in is called VDMX_handler_sub_address. I did it that way because you can't rename sub, you can't have a function name that starts with sub underscore in IDA unless it's not at the beginning. And I named it VDMX handler because that was the 4-byte CC that it was parsing. And then I do another bad habit here where I name a function verify seek doesn't exceed bounds. So I'm trying to summarize the entire function in the name of the function. That's a bad habit. Here I'm actually declaring one of the registers, EBX in this case, to be an object, and then that applies to from here up. So I'm trying to introduce a little bit of type information. And then here I kind of decided to use IDA structures. As you can see, I have a structure like a pointer to a VDMX dot offset. So I'm actually using IDA structures for that. And then I've got over here, it looks like I tried to decompile it a little bit into something that looked kind of like C. So as you can see, all of this is text-based. All of this is if I don't keep my naming scheme the same from IDB to IDB or from team member to team member, he'll have no idea what the hell I'm talking about here. I can't give him this and have him work on it. It'll take him a while to sit there and read and figure out what I'm doing. So everyone reverses differently is the point. Here's a screenshot of someone else's IDB I found online.
This is from Sebastian Forrest from he used to be with Dynamics at Microsoft, and I wrote an MSDN plugin, and literally it's an optimization to prevent him from, here's the assembly, let me switch to the documentation. Now it's all right in front of you, so you don't have to do context switch to understand exactly what it is. And you can see this is incredibly detailed. I only see, 10, 11, 12 instructions on here, and all of it's just text. So which do I read? Do I read the assembly because I understand the scope of it, or do I read the text that's going on? And then not only that, what if we have some other insight? Do we replace a comment? Do we discard the previous information? So there's no way to really reuse the space that IDA gives you to be able to document what it is we're trying to understand here.
And then you've got, I found this screenshot online as well. And as you can see here, this is someone essentially trying to avoid reading assembly. They don't want to learn assembly apparently, or they want to convert it to their intermediary representation.
Assembly's hard.
And yeah, assembly's hard. And they have comments for every single instruction, and it looks like an intermediary representation because they're doing lows and stores and arithmetic. But they're not reading the assembly anymore. They're reading their comments.
So it's like an IR. So another thing, which we pretty much put together a bunch of little hacks and things we use to get around IDA's we consider limitations. IDA's really bad at correlating, I guess you could call it graph data, right? Because there's hierarchies in function. Function calls function calls function calls function. Well, we have cross-references, but what if you have 126 cross-references? How do you know which function you really care about? Well, if you see, all they give you is text, so you use a comment. We use 3 X's, just like in C code, like a fix me or a to do, to be which 126 functions? Hold down. Oh, that's what I care about. And then that way you can be okay, this is how the hierarchy is. This is the execution flow of how the program is executing in order to exploit this bug. So another thing, this is also the same type of deal, hierarchy, right? Inside the scope of a variable, scope of data structures, you essentially need to keep track of where it's instantiated, where it's used. It's essentially a tree structure. However, we're using marks. This isn't a tree structure. We have a flat pane to be able to document all of our marks and correlate them together. As you can see, I did this really late. This is one of my marks in one of my larger databases. I use numbers. Some people use tabs or spaces just to draw a hierarchy that can be comprehended. Like 6 call component. This is from QuickTime. Like, I wasn't sure if it was 6 because, you know, I mean, I didn't want to spend that much time reversing, but I knew it was around there. And as you can see, this is horrible. If I pass this to Aaron, he'll be like, Ollie, what are you doing?
Yeah. These are basically stack frames. So he's just trying to make a stack frame in a marked location, like via marked locations, which is, again, it's all text. How are you going to parse this? Right? You're going to write code that's going to rip through your IDB and grab text out and like try to figure out was it a 0 or a 1 and what's a question mark mean?
Yeah.
Like it's kind of tricky. And here's one of my stupid little hacks, very simple, but like when I'm reversing, whenever I get to the function epilogue and I'm in a debugger and in the disassembler, I just put a comment on the return address that is the address of the caller. Because if something is called 126 times or whatever his was, it's nice to have like a little place you can just double click and it brings you back to the caller. However, the more you end up starting to do this, and maybe if your clipboard's messed up and you paste the wrong address, you'll really screw yourself over. Okay. You can screw yourself over because you'll get confused in the context and how far you went. All right.
So what does all this have in common? Again, the only thing we use for all this is cross-references, naming information, and comments and marks. That's how we've always correlated all our cases, because that's what IDA throws at you. It throws it in your face. Its interface is awesome for that. So if we look at it, well, human beings are awesome at reading text. We could read text all day. You know, we could read assembly all day, but how do you write a program that parses text? You get a natural language parsing? No, screw that. That is super difficult. This is not generalized enough for it to be a database.
Yeah, so basically, the way that IDA provides it is manually, IDA API, IDA utils, using all those IDA Python functions, but it's not a database. IDA calls an IDB a database, but we have a quote here from Postmodern where he says, hey, InfoSec, can we stop calling wikis databases and replace wikis with IDBs here? If I can't query it, then it's not a database, and that's very true. IDBs, you can only query them via those APIs, and they're very limited. And they don't allow you to store information other than in text, again.
So, databases, right? Essentially, code execution isn't just, you know, with all the cross-references and comments and everything, that's pretty much a graph database, which means if it's a graph database, we want to traverse the graph to understand all the attributes that are coming out. In this case, I've only used two different people's projects to simulate a graph database. One of them is PyMate, written by Pedro, and the other is BinNavi, written by Hotlar Flake. And both of them provide an interface to be able to do graph traversals on the entire database, because IDA was missing it at that point. So here is BinNavi's database schema, right? Essentially, this entire thing is a graph. If you want to do a query, you would do your joins, blah, 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 to get to your expression tree, and then eventually you'd use that to comprehend maybe comments to give text to people so that they can understand it. So graphs are based on nodes and edges. When you slice a graph, you get a tree. You get like an execution tree out of it. And then from that tree, you would care about the attributes that you would care about, which presently, all we're using are comments, naming information, documentation, and other information like that. With enough attributes, you develop what's called an attribute grammar. Based on an attribute grammar, you can collect attributes and build something more complex, and then you get into the higher level computer science, you know.
So basically, graphs represent code flow. We're going to speed it up a little bit because we're running out of time. We have a demo to show too. So basically, graphs represent code flow. When you slice out, you have this huge tree of the whole module, and you care about these functions, and then you slice out inside that function. You slice out, a subset of that function, which is a tree, and you can flatten that into a list. So for example, here's a big function. The green represents one path, and the brown represents another path. To begin with, that's a function. And then the brown could be a tree that you slice out of that function, and likewise with the green. And then you can even select, ideally you'd be able to select based on attributes within those trees to be able to ask it questions, essentially.
Common one, this is just really lazy debugging, right? We have a function with, let's say we counted, I don't know, I'll pull a number, 500 conditional branches. Nobody manually wants to reverse that between like 6 functions deep, right? So in this case, you would just go through and mark, this is a conditional branch. Then you flatten the list and be like, on your debugger, break here, capture the flag state to figure out which path it takes. And eventually, you have an execution path that you carve out of the graph, which is useful for documenting how data structure is used.
So So you've got, we're going to go a little quicker. I'll let you get to it. So operations on trees. Basically, there are many things you can ask a tree, like questions you can ask your IDB or questions you can ask this data structure. You can ask it, you can populate it with runtime information and populate all the dynamic calls. You can do complete static analysis with taint analysis, and you can track different variable scope and how your data may flow through an application. And you can, when I say object scope, I mean, say you enter a function and you see that they're using the this object and they're pulling that off as a C++ this object, right? And then they're using that throughout the function. Maybe it's a really big function. I'd like to be able to just say, give me only the basic blocks where that's being used. I don't care about everything else. Or give me all the functions that this function calls where it pushes that argument. And you can be able to ask it questions. You can do things like what we call cutting the fat. And cutting the fat, I just mean, say you're reverse engineering a program that has a user interface, a graphical user interface. Do I care about window messages? Do I care about GUI code? Do I care? No. Slice all that out. You have a big graph, cut off all the pieces you don't care about, and just look at the parts you do. So this leads into, like, if a woodchuck could chuck wood. And what we mean by that is, like, what would you query? What kind of information do you care about querying from subgraphs or trees? So basically you have things like clobbered registers. That's useful for taint analysis. You've got stuff like the calling convention, frame size. Does it call local? Does it call functions within this module? Does it call external functions? Does it call library functions? Does it deal with dynamic memory? In other words, is it doing heap allocations or heap frees? Is it doing, does it have, what are the input-output registers? Is it a pure read function or a load, or is it a store function, like a write?
It lets you quickly scope out, do I really want to reverse this? This calls this many library calls. If I look at these library calls, I probably have a general idea what this is going to do, so I don't even want to descend into it. So, with this, presently, the way you query stuff is, here's my giant data set, do a for loop through it, and stash it, and then process it later. The thing is like, you need some way to select exactly the constraints of your giant data set, because you don't want to do it over the entire function or everything you just ran. So with this type of mechanism, you see the for loop, do all the functions, get the head, and analyze the instruction, right? Just like IDA's analysis, there isn't any cheap, easy way to query it, to query what data you care about.
So we basically, we work around this. This is what the current solution is. You work around it. You work around it by the only storage capacity IDA gives you essentially is text and text, naming, and cross-references and marks, that kind of stuff, which is all basically text representation of whatever it is you want to put in there. So comments are keyed by address. Marks are out of band. They're just like bookmarks. So basically, the first approach we did to solving this was we formed a very basic syntax for comments that we could store in an IDB and easily parse. So that looks something like this.
Yeah, so this is QuickTime. Inside QuickTime.qts, there's a bunch of dispatch calls, right? It takes the magic number, which is your code, that seeks into a giant function table, and then that's where your real code is. So if you're statically reversing this and you don't want to sit in the debugger, like, there's no way to get the correlation. You see the address right there or the real name? There's no easy way to get that without sitting in the debugger. So with tagging, you just process this once, and this is the information that we share between our entire team. And with that, you should be able to reverse QuickTime bugs a lot easier than it was before, with spending less time inside the debugger.
So, yeah, basically we're just saying this is not a legitimate graph query. It is, let's use IDA's functionality with IDA utils and IDA API to query functions to then iterate over instructions to then get the comment and then parse out a tag. It's not a database quite yet.
Still working towards it.
So the next thing we started to do was we basically we're like, how can we store all this information not using IDA's limited capacity to store things? So like, let's offload the database to an actual database. So let's do a transactional database. So IDA is not transactional. From their blog, they say specifically, why is there no undo option in IDA? Because it's not a transactional database. So basically, if we're going to make a transactional database, what is it we're going to store? So we have to revisit this retention problem. How do we restore, like, how do we keep all the information we reversed? You know, everything IDA is capable of and all the other stuff you can do, all the things IDA enables you to do. It enables you to generate breakpoint commands. I can crawl an entire IDB, find all the MSDN libraries, pull their function prototypes, generate breakpoints, and push them all over to a debugger automatically. I'd love to store all those breakpoints and all that information and maybe return values and addresses and all that in a database so I can query it. Type information, hit traces, or instrumentation, say you're instrumenting a particular module or you're debugging it. I'd like to be able to take all that information from the debugging session and put it into a database. So this is basically what we implemented.
Yeah. So with querying, again, how do you constrain your data set? Well, it's really simple. All we wanted was and, ors, nots, and depth. That way you can query inside your entire tree. I only want everything that calls malloc and everything that calls free, and I only want it to see 6 steps deep. At that point, you could be able to understand exactly, or select the scope it is of what you care to understand.
And all right, so we're going to finish it up here quickly, and then I'm going to show you a bunch of code that does all this. It'll make sense when you see that. So we're just summarizing our capability. At this point, we've basically implemented a database that's outside of IDA. We have a query language for querying it. We have a way of tagging that information. We also have partial evaluators that we wrote that allow you to collect attributes and stash them to the database however you want. And you can take advantage of all the IDA's analysis to collect such attributes. You can store it all in the graph database, which is persistent. You can query trees out of it arbitrarily, and you can display that information however you want to. So,
in summary, that makes it a model view controller framework. Your model is generalized enough to be able to select what you care about. Your view is how it's displayed to you, and if your controller is still not a computer program, but it can be a human or a robot, thus augmenting your reversing capabilities.
All right, so real quick.
Sorry for being so quick, y'all.
All right, so this is Windows Media Player, one of their DLLs. And I'm just going to show you so IDA 6.2 or 6.1 introduced IDA QT, or QT inside IDA. So you can actually write your own interfaces. PySide. So I wrote a UI. I'll show here. Let's go here. So one of the biggest problems with IDA is when you're reversing, you don't have scope, you don't have context frames, you don't know where you came from, you're doing it all via text. So basically, say you're reversing here, right? I basically wrote it such that we're using our database to store all the nodes and edges for every function we're in. You hit a key combo, wherever you are, and it adds it to the graph. See it there? Now say I go to a call, key combo. See? So basically what this is doing is adding everywhere you've been.
Yeah, and this is perfect for sharing with another person who's working on a case. Like if Aaron wants to share this with me, he'll be like, this is the case that does a quick time overflow in PIX patterns, right? And that way he just shares this with me, and as I reverse it around and I find another bug. Well, I have a different view, and we can pass these views back and forth to share information.
So at this point, we're like, okay, we have this great graph database. It shows everywhere we've been. We can click it and all that. How do we store it? Do we want to store it in the database or what? Right now, it's operating on the database to create this and doing the graph traversals. So what I decided to do was actually make a file system inside of IDA. So I actually have, what I do is I make a new segment in IDA. I call it .zip. And what it is it's actually just like a key store. It's a zip file that's stored in your IDA database. Okay? So, for example, this is a tree object. So I can go ahead and do save. We'll call it, actually, I'll call it Aaron. Okay? Now, if you go to the file system browser, you can see that there's a file called Aaron of size 539. What that is a pickled Python or serialized Python object. So, say Ali, and say I want to give it to Ali, right? So I give it to him, I clear my history, Ali's working, say he's working around here, and he adds these two functions, and he saves it as Ali. You can see we've got both of them here. And I could give him my IDB, and he could go, oh, I wonder, I looked and saw, look, it looks like Aaron did some work on here. Let me load what Aaron loaded. And then it loads back up the graph of everywhere I've been. And in addition to that, you can click these and add notes here that'll load and all that kind of stuff. And you can actually collect all sorts of information beyond that. But this is like the most basic, of how you keep track of where you are in IDA.
Yeah,
we also,
the important part of all this is it's done completely outside of IDA. It's backed by a real database. So you can take all the same information, all the same IDA database, and if you're scripting a debugger like PyDebug engine or anything like that, you can query the database, or if you're instrumenting, you can load the database in your own process and still have access to it without depending on this program.
And then I wrote this with, actually Peter on my team wrote some pathfinding code, and then I ported it to use our database, so it's pretty quick. And basically what this is, all these functions are already in the database, so I can say, I'm reversing right here, all right, let's store that address as the source, and let's go, say this is another function, say this was a vulnerability I found. I'm like, man, I wonder how to get there. Well, then you can click this, and it basically will do all the path traversals, and it figures out, all right, that's how you get there. So here was our starting point. Here's the function you want to get to. So you can kind of like, and this can be arbitrarily complex too. I mean, obviously if you run it on the whole database, it's going to be slow as hell, but you can run it on quite large ones, and it'll plot you all the different ways to get from A to B, which is quite useful.
This is super useful for finding things that manage your heap, because A lot of times, like, here's my scope, here's the paths to use from heap to use or free to use. And you can use that, again, to aid you in exploitation.
So I think we're out of time, but it was a lightning talk, so hopefully if you guys have any ideas for us, or if anyone's working on anything similar, we'd love to talk to you guys. So we're out of time, though. Thank you.
¿Alguien quiere hacer alguna pregunta? ¿Sí? ¿Questions? Hello. Nice idea and good presentation. My name is Roman, and my question is a simple one. When you work on the same project, how you deal with collisions? I mean, do you use a system for controlling versioning or something like that?
Are you talking about things like Collaborate? Yeah. So we haven't really visited that problem yet because it is a hard one. But I think what we're thinking of doing is using the fact that we have persistent storage outside of IDA to leverage that somehow to synchronize. The biggest problem with IDA is there's no lock on the database. So if you have concurrent writes to it, you're going to mess something up. So I think we can use the database. We haven't written any code for it yet, but we've been thinking about it. We don't have anything yet.
¿Alguna otra pregunta? Bueno, nuevamente muchas gracias, chicos.